Hi students, this is Kyun. Actually, I forgot to record today's laboratory work, so I will try to re-record it before I forgot the material. So let me start with the material by sharing the handout. Um, so today we have learned what is heap with a complete binary tree. So actually, the complete binary tree is different to the full binary tree. So I explained it before that the full binary tree has all the nodes at the end is attributed into full. So for a binary tree, you may think about that uh, if a tree with this shape with all the nodes at the leaves are in the same level, same depth, then that is a full binary tree. So it is called a full binary tree. And the complete binary tree may be some of the leaves may be omitted at the same level. So these are also the leaves. So there is at most one level change, but the leaves should be filled from the left side. So it is not possible to have some missing leaves before the right end. So this is called a complete binary tree. So the heap is a complete binary tree with two constraints that one constraint is that the root is the maximum. And second constraint, that shape should be preserved at the subtrees. So that is those are two constraints. So the complete binary tree can be expressed by an array because you may think about that it is scanned in this direction, scanned here in level order, and then finally it terminates. So there's no missing part in the array representation. So if you like to represent this an array, if the index starts from 1, then 2i is the left child. For example, if the index is 1, then this is the root, and the left child should be 2, and the right child is 1 plus of the left child, 2 and 3. And the same holds for the for other nodes. For the left child of 2 is 4. The right child is 5. Okay. So in this way, you may consider that the left child should be accessed 2i left, and the right child should be accessed 2i plus 1 right. So what if you are considering an array starting with 0? This is more frequent situation since C and C++ Java always starts from the index 0. So it is hard to understand starting from 0. So let's think about from 1. So what is the left child? Left child of 1 should be 3, which is 2 times I plus 1, since 2 times of 1 is 3. So how about for right child? This is left. Of the right child, it should be 1 plus of the left. So 2i plus 2 for the right child. If your index starts from 0. So let's just check that it is also holds for 0. How about 2 times I is 0 plus 1 is 1. Okay, so it holds for 0. And plus 2 is the right one. So with this observation, you can represent a full binary tree with an array, and the left and right children can be accessed with the index operations. For example, the following code shows how to produce an in-order traversal of a complete binary tree. So let's take a look at the code. Since it is binary tree, so let's start from this example. So you may consider that this is the root. 27 is the root, and the left child is 14, and the right child is 35. Okay, and the left child of 14 is 10, the right child is 19, and left child of 35 is 31. So it is much like a binary search tree. So if the binary search tree is a complete binary tree, can be represented in a complete binary tree if it's possible, then the maximum depth is minimum. So with this setting, you may access in-order traversal to see out the in-order is using the auxiliary procedure of in-order with index. So for those, you have two public methods, which is a constructor, and second one is in-order traversal. And you have private methods, which is in-order with index, and it has two member variables, elements and size. So let's take a look of the complete binary tree of constructor. It is accepting the parameter size and ns. The size is initialized the size, and this code is just allocating the elements and initialize them by copying the contents of ns. And in-order traversal is calling in-order with the index, which is the helper function. So in-order with the index is called here with 0 and out, and 0 is the current index. So since it is in order, you have to access the left child from I times 2 plus 1, which is the left child, when the index starts from 0. The right child is I times 2 plus 2. Since it is in order, your root is printed between these two recursive calls. So with in-order traversal, you may produce this from in order of this is the in order of this first. So the in order of this is printing 10 first, and then 14, and then 19, and then 27, and 31, and 35. This is the in-order output, the order of nodes of in-order traversal. So let's take a look with this code in your Visual Studio Code. So let's save this a little bit, delete all the things, and I'd like to reshare the screen with Visual Studio Code. So I already created the file cpt.cpp, but I erased all the contents. So let's start from include iostream, and you are using namespace std to make it convenient, and you'd like to make a class complete binary tree with the members LMs, which is an integer pointer, and size, and the class should be terminated by a semicolon. And the public as a public method, cb3, which is a constructor, is accepting size and numbers, integer array numbers. And the size is initialized with size, and the contents of it is for allocating elements for new int with size. And you are going to use for loop starting from 0. If it is less than size, you are incrementing it after copying the contents of ith element into LMs. Okay, and next public method is in order. So void in order is accepting all stream reference out. So it is calling in order with index starting from 0 to out. So these two methods are public methods, and this is automatically private. So let me just make it explicit, private. And in order with index should be added as a private method. In order with index with an integer current index I with the all stream reference out. So it is checking that the current index is in range. So if I is, it is not the case, but I like to check it for sure. I is less than 0 or I is greater than or equal to size, then it is out of range, so return. If it is not, we'd like to in order with index of left child, which is 2 times I plus 1 to out. And in order with index 2 times I plus 2 to out. So if you want to make it really in order, you have to print out the current LMs of ith index and line. So with this setting, you can make a main function. You are going to declare ns as just 1, 2, 3, 4, 5. Okay, and the size, this is an idiom. So it is the size of ns divided by size of an element, the first element. So size of ns means that the whole size of the array, entire size of the entire array, and ns means size of asterisk ns means is the just the size of the first element. So you may make a cb tree, complete binary tree is accepting size and ns. And you'd like to invoke in order traverser to see out. So let's save this. And you may want to try play, which is installed using, it is installed using code runner. Okay, we installed code runner then, and then the play button is created, and you just click this to make a run of it. So it is truly executed. So let me just check if this is correct in order. So let me just enlarge the terminal a little bit. 3. So this is not. So in the previous case, you have learned up to 6. 6. Okay, we may try that later. Okay, so this is the output. So let me just draw the complete binary tree first using using a pen. So you know that 1 is the root. So 1 is root, and 2 is the left child. So 1 is root, 2 is left child, 3 is the right child, and 4 is the left child, 5 is the right child of 2. So the in order is 4, 2, 5, 1, 3. So 4, 2, 5, 1, 3. So let me just make it enlarge this a little bit with 6. So you just make an increment of an array, and all the other things can be performed automatically. So you save this and run this again. The result is that, okay, can you find that? This is 6. 6 is the left child of 3. So the in order is 4, 2, 5, 1, 6, 3. Okay, 6, 3. So this is a simple representation of a complete binary tree. Okay. So let's switch to today's problem. So today's problem is for making a heap sort. So write a program to sort a sequence of integers using a max heap. Just insert integers into a max heap and delete from the heap to generate a decreasing sequence of integers. So you just make a heap using an array. So let's make it. So while it is making, you just insert it in the correct location. So once it is empty, just add the first element. And you'd like to add 5, and then the correct location is 5. Since it is complete, you just make a 5 here, and then you repeat up. So 5 compared to its parent, and the parent is less than 5, so you just swap this 5 and 1. Okay, and inserting 2, the next position is here. And you know that you'd like to try this lift up, but 5 is greater than 2, so it is the correct location. And 4, you just insert 4. This is the next location, and you want to try this lift up, and it is truly that 1 is less than 4, so 1 is dropped down here, and 4 is lifted. And it is tested again. If 4 is greater than 5, it should be lifted up, but currently 4 is less than 5, so this is the correct location. How about 3? So you just insert 3. In that case, 3 is less than its parent, so this is the correct location. So you made a heap 5, 4, 2, 1, 3. So from this, you are deleting the root. So deleting the root, 5 is created. So 5 is created, as the first element, and you have to fill up the root since it is empty now. So you just delete the last node, and 3 is made here. And then it is going down to find the correct location. So the comparing these 3 nodes, what is the maximum? 4. So 4 should be lifted up, and 3 should be going down. And this procedure is performed again. Compare 3 with 1. It is greater than 1, so this is the correct location. And then you are removing 4, which is the second trial of the second maximum. So 4 is deleted, and the last element is 1, so 1 is moved up here. And then you are trying to going down 1. So you're comparing, so it is too complex. So let me just make it more visible. Okay. So all the things is already deleted. And currently heap consists of just 3 nodes. Okay. And you know that this is 1. And you're comparing 1, 3, 2, which is the greatest? 3. So 3 should be lifted up, 1 is going down. Okay. And the next element, 3, next root is deleted. And what is the last element? 2. So it's moved up here. And it is tried to going down. And truly 1 is less than 2. So it is in the correct location. So what is the next? 2. And 1 is moved to here. It is trying to going down, but nothing left. So you are producing 5, 4, 3, 2, 1, which is a decreasing order of the 5 numbers. And as you know, these numbers this sorting may be performed in place. Okay, so for in place, you are going to make a heap. So let me start with the first heap. 5, 4, 2, 1, 3. And you know that heap is up to this point. Okay, from this point you are removing 5 to the last element, and then you are making 3 to the first element since it is the last. So you want to make a heap up to here, 2, 4. So it compares 2, 3, 4, 2, and 4 should be lifted up, and 3. Okay, and then 4 is moved to the second from the last. So 5 and 4 is moved up to here, and you know the heap is up to here. Okay, so the element 2 is lifted up, 3. Element 1, sorry, element 1 is lifted up, 3, 2, and it is going down. What is the maximum? 3 is lifted up, and 1 is going here. So in this way, you can make a sorted list in reverse, 5, 4, 3, and then your heap is maintained to here, 2, 1, and you are removing 2, and your heap should be maintained up to here. So the resulting array is sorted in an increasing order. So your current array is sorted in place. This is much like a heap sort. But for today's problem, you are just using practicing the heap. So you do not use the in-place sort. Okay. Okay, so finally, the last element is deleted from the heap. Since you have to check whether the heap is empty or not, the class heap should support the Boolean method is empty. So it should also support add, remove, and the size methods. The method size should return the number of elements in the current heap. Your program should read from standard input. The first line of the input contains a positive integer n, which is the number of input integers. And the second line contains n integers separated by a space. Your program should print the result to standard output. The result should be the decreasing order of integers. Note that the trailing space should not be printed. So you know that you can use the technique of the conditional operator to omit the last trailing space, last space. So you may check the input and output. For additional requirement, you are going to try to overload at least 2 useful operators to use them. For me, it is empty may be checked by a unary operator, and insert may be used insertion operator, and delete may be used extract operator. So you may try that for an arbitrary operator with a meaningful one. So if you're going to take additional bonus point. Okay. So that's it. So thank you for joining this lecture, and may all of you take full points.